All right, today we're going to tackle encapsulation, one of the big four pillars of modern programming. Now, it might sound a bit technical, but I promise you it's a super powerful concept that you actually use every single day without even realizing it. So let's break it down.
Okay, to really get what we're talking about, just picture this for a moment. What if you downloaded a new game and that game could just reach directly into your banking app and change your account balance? That'd be terrifying, right? Well, preventing that exact kind of chaos is precisely the problem that encapsulation was designed to solve.
You see, way back in the early days of programming, this kind of free-for-all was just how things were done. Different parts of a program could directly access and change any piece of data they wanted. It was a system built entirely on trust, and as you can probably guess, that led to some major problems.
And what a mess it created. You had wrong values getting plugged in, data being changed completely by accident, and bugs that were an absolute nightmare to track down, and security practically non-existent. The goal, the big dream, was to get to a world of controlled, predictable changes and, of course, high security. So how do you even get there?
Well, you get there with a really elegant solution. I want you to think of encapsulation as the hero of our story. It's like a protective digital capsule that finally brings order to all that chaos. It's this core idea that says, hey, we need to build some really strong walls around our important data.
Okay, so what is it officially? It's the practice of bundling two key things together: the data itself, like your bank balance, and the specific approved methods that are allowed to work on that data, like a deposit or a withdraw function. You wrap them all up into one single secure unit, and we call that an object. Look, if you only remember one thing from all this, make it this equation right here. Encapsulation equals data protection plus controlled access. It's not about locking data away and throwing away the key. Nope, it's all about making sure it can only ever be accessed or changed through safe, pre-approved channels. That's the key.
Okay, so we've got the what and the why down. But what about the how? How does this actually work in the code? How do programmers go about building these digital safes?
Well, you might be surprised, but it's a pretty simple two-step method. First, you hide the data. You mark your really important variables as private, which is like slapping a giant do not touch sign on them for the rest of the program. Simple enough, right? Then, step 2. You create public gates. These are special public methods that are basically the official gatekeepers. They are the only safe way in or out. Let's go back to our bank account example to make this super clear. The actual balance variable, that's private. You can't just reach in from some other random part of the code and set it to $1 million. No way. But the deposit method, that's public. Anyone can use that method. But here's the kicker. It has rules built into it. It controls how the balance is changed, making sure it's all done safely and correctly.
And here's the really cool part. This idea, it is absolutely everywhere in the real world once you start looking for it. When you use an ATM, you're using a public interface, the buttons, the screen, to interact with very private data, which is the bank's central database. Or your car. You use the pedals and a steering wheel. You're not down there manually fiddling with the engine pistons. It's the same exact principle, encapsulation in action.
So let's zoom out a bit and really talk about why this one idea is so incredibly important. Because it's not just some neat little trick for programmers, it's truly a foundational concept for building any kind of modern, reliable software. I mean, the benefits are just huge. Right off the bat, your code becomes way more secure because that sensitive data is protected from misuse. It's far more reliable because you get rid of all those accidental changes and the nightmare bugs they create. And all this organization, it makes your code so much easier to maintain. But maybe most importantly, this is the very bedrock that lets developers build those massive, complex applications, the ones that not only work today, but can grow and evolve over time. And really, it all comes back to this one core message. It's that simple formula, data protection plus controlled access. By bundling data with the methods that control it, encapsulation creates software that is robust, secure, and just manageable. It's a simple idea for sure, but with some pretty profound consequences. So I'll just leave you with this final thought. Once you start seeing it, you can't unsee it. You'll notice this principle everywhere. A simple, clean interface protecting a really complex system underneath. So my question to you is, what else in our daily lives is secretly encapsulated, all for our own protection? Something to think about. Thanks for tuning in.